In this video, we demonstrate how Harold's XY module can be used to simulate a ridge structure. This is the epitaxial layer structure with the quantum well in red. And then if I click on the cross-section node and visit the mode solver region, what we see here is the right-hand side only of the ridge structure. Because there is a symmetry plane down the center of the ridge, we only model half the ridge for efficiency. If I click this button here, Harold's got a built-in mode solver that will calculate the modes of this ridge structure. Notice that we're viewing the full XY profile, even though we only see the half profile here. This is the fundamental mode, and this is the first order. So this ridge structure has two modes of TE. The 100 here in this list here means 100% EX polarized, which means TE. Then in the device settings, we specify as a 600 micron cavity with left and right mirrors having 30% reflectivity. So in the simulator, we can just do the simulation. But before we do that, one thing to note in the options, of which there are many, is an option here called Recalc Modes at Each Bias. This is telling Harold to recalculate the modes at each bias step, just to take into account the heating effects and the consequent change of modes in the active region. And this is set to be on using a first order perturbation method. So we click Start, and it'll take a short while to calculate. When the simulation is completed, we can click the Inspect button. And we can plot various items. First, let's go to the versus bias grouping of data and look at a few things. First, we can look at the total optical power at facet 2, facet 1. So as a function of current, the optical power emerging from facet 1. You can see there's a slight thermal rollover as we get to the top of this graph. Now, because we're simulating a ridge laser, we can model the modal powers at facet 1. So you can see here in this case we have two lines on the graph. The blue line here is the power emerging in the fundamental mode. And this here is the first order mode, which you can see switches on at around 65 milliamps. There's various other things we can plot here. One thing that is quite interesting is we can study how the modes change as a function of the bias. So mode width and mode height. Might be slightly easier to plot them separately. So this is the mode width, how the mode width changes of the two modes depending on current, and the same for the height. The HAROLDXY module also allows us to plot things such as material and profile results. So if I select the profile option, we can plot things such as total current density, but you can see here it's a very wide laser, so let's reduce that from -2 to +2 and plot again. And here we can see the total current density in the area of interest, and you can certainly see there's lateral current spreading. We can do the same for electron and hole densities, for example. And various other plots like that. Finally, we'll click temperature, and you can see here the temperature change across the XY cross-section of the ridge waveguide, ridge laser. Notice that this is done for a specific bias. So if we wanted to change which bias we're looking at, we use it from the drop-down list. These are all the increments of the simulator that was defined here. So at the moment we're plotting at the last bias in the simulation, but of course we can see how it changed throughout the simulation at each step. And for each step we can also view the modes for that step and have a look at how they are, their effective indices, and all other properties associated with the modes.